You don't need one.
What about 0.1 times 6?
I think you can do that one.
Is that 0.6?
Hey! It's okay. Now that we have gotten almost.
0.1 times 10 is.
Alright, so we're going back to our distributive properties. So if we distribute the multiplication of our 2 to the x, what is 2 times x?
Times x is 2x.
And what is 2 times 6? 12. Good. Alright, so now we're distributing our x to our x squared.
X to the third cubed.
Good, so x cubed or x to the third power, however you want to say it.
Cube.
Plus 6x.
Wait,
And when we-
cubes have like what, 4 sides?
We have 6.
Wait, why is it not 6 then?
How many sides does a square have?
True.
4. Are we talking like cube or square?
We're talking about a square.
Oh, 4.
It has to do with the number of dimensions. Alright, so x times 6. When we distribute the second one, we get what? 6x, very good. Alright, so just because I know 3 looks a little scarier, a little different, the negative 3 is now on the right side, but it works the same.
Yeah, do.
So what's negative 3 times x? And negative 3 times x. Alright, there's a lot of cheddar. That's not about our distribution. Alright.
Wait, why is it minus 10?
Because we have a negative 3 times. Alright. And our last one, 0.1 times 6.
0.6 plus
0.6 and 0.1 times 10x.
1x.
Can I write that as x?
Yes.
Is that okay?
No.
Follow me?
It's correct.
I got you.
Alright.
Because like everything you do there's so much slower than actually doing it.
I'm sorry. It is a little trippy. Alright. So the new concept we're going to learn today is called the simplest radical form.
Sounds dumb.
Radical.
So remember when we learned about simplifying fractions and their reduced form? Right? Fractions have a most reduced form.
Yeah, simplify it.
Simplest?
Simplest.
Factor it out.
I
Alright.
like simplifying.
So now we're going to learn how to simplify something with a radical sign. Someone remind me what a radical looks like.
A square root.
A square root, right?
Yeah.
So there's my radical sign. Our radical. Alright. So simplest radical form. This is an expression.
Oh. Snap. Never mind, don't do that.
Okay, it's an expression that satisfies 2 conditions. So we're going to say with, and I'm going to list them separately. So 1, has no perfect squares under the radical. Alright, so there's no perfect squares under the radical. And 2, there are no fractions under the radical.
Wait, does that mean we'll have to do a factor thing?
It does not. Just means we don't want any under the radical. Okay, so something that is written in simplest radical form has no perfect squares under the radical and no fractions under the radical. What is a perfect square?
It
Say a
is.
square with the same number of stuff on each
It's
side.
like 1 times 1, 2 times 2.
Okay, so the perfect squares are, we'll start with 1 times 1 is, so if you do not know all of your perfect squares, this is a great time to write them down. So 1 times 1 is 1. What's 2 times 2?
4.
9.
3 times 3 is 9.
16, 25, 36, 49, 64.
Alright, so Angelo is using a very good resource. For those of you who still have your multiplication tables, if you remember, Mr. Fisher gave you a great idea to highlight your perfect squares. So if we go back and look at those, so it was 1, 4, 9. So I'm looking at 4 times 4. 16.
25.
36.
Alright, I know. You want to give one too? Alright. So we said 16. Now we're at 5 times 5 is 25. 36. 49. We're at 8 times 8. 64.
81.
81.
100.
100.
121.
121.
144.
And 144. That's up to 12 squared. I think we'll be okay with that for today.
169.
Alright, so we're up to 144. So these are all of the perfect squares up to 144. So we want to make sure that we know these.
100 times 100,000, 10,000.
It's got 4 zeros. 100 times 100 will have 4 zeros.
10,000.
Yes. Alright, so we don't want a perfect square under the radical. So I'm going to kind of show here why. So remember I said like fractions, we simplify them. We want them in simplest form. This is us putting something with a radical into simplest form. Okay? So an example that we're going to put back up here in our simplest radical form is something like the square root of 8. So this is not in simplest radical form. So I want to know, are there any perfect squares that go into 8?
4.
There's 4. And if you weren't sure, find about where 8 should be on this line. It's about right here. And you're going to move to the left. So we want things that go into it. So does 4 go into 8?
Yes.
It does. 4 does not go into 8?
Well, it
4?
does, it's just not perfect square.
8's not a perfect square, but 4 is.
4 is perfect square.
Right.
It doesn't go into 8.
Okay, hold on.
Just stop confusing yourself.
So I'm going to rewrite this as that perfect square times, so what times 4 gives me 8? 2. So the square root of 8 is the same thing as the square root of 4 times 2. And we can break this apart, right? So this is the same thing as the square root of 4 times the square root of 2. Do we remember that we can break apart square root signs that way?
Yeah.
Okay. What is the square root of 4?
2.
So now we have that the square root of 8 is equal to 2 times the square root of 2. And are there any perfect squares that go into 2?
1.
Okay, there is 1, so we can add this except 1. Because we could sit and take 1 out of everything and it would never change it. So there's nothing smaller, no perfect squares except for 1 that go into 2, so we're all done. So this is something in simplest radical form. Okay? We feel a little okay?
Wait, so we get marked down for this, like the square root of 4.
Right, because there's a perfect square under there. 4 is a perfect square. Okay, so let's try some of these.
If you did that with times 2 is 8. Wait, what? And do have 4 times 2. What's that? The square root of 4
Times the square root of 2. Yes, you can break that apart.
But isn't that the same thing? Wait, then why would you change to 2 times
Okay.
the square root of 2?
So I broke this apart because I know what the square root of 4 is. So I can simplify that to be 2. So I got rid of part of my radical.
I'll take your word for it.
So then you just bring down the other part?
So this is this. I just ran out of room. So the square root of 4 is 2, and the square root of 2 is still the square root of 2. So this is 2 times the square root of 2. So I simplified what I could. So let's try our first one, which is the square root of 48. So is 48 a perfect square?
No.
No.
Does it have a perfect square factor?
Yes.
Yes.
Where is 48 on here?
36.
No.
Right here? Ish?
Yeah.
So now I'm going to go to the left. Does 36 go into 48 evenly?
Yeah.
No.
By 12.
What's 12 times 36? It's not 48. So 36 does not go into 48. Does 25 go into 48?
No.
Does 16 go into 48? Yes. So that's where we're going to go. So we're going to rewrite this as 16 times what?
48.
3. So we want this multiplication to be equal to 48. So 16 times 3 is 48. All right?
It'd be good for you.
Now I want to break this apart so that I can get rid of part of this radical. So this is the square root of 16 times the square root of 3. What is the square root of 16? 4. And can I reduce, or can I simplify the square root of 3? Do we know what that is?
0.5.
It's 1.5. No, I don't know.
1.5 times 1.5.
What do you mean simplify it 3?
Wait, what?
It's not an even number. So we're just going to leave that as the square root of 3.
I don't get it. So wait, is it 4 times?
It is.
What was
So when there's
1.5 times 1.5?
1.5 times 1, what's that? 0.75? Wait, 1.
Because 1.5
Yeah,
is 1.5.
It's 9/4. Alright. So I could write this if you need a middle step. So this is 4 times the square root of 3, which is equal to 4 roots of 3. We can write it without the multiplication. So just like when we have a number next to a variable and we don't write anything in between, that's multiplication.
Do 1.75.
I think so. Alright? So we can write this the same way.
It's half of 1.5 is 7.75.
Alright. The point is the square root of 3 is not 1.5. Okay. And then we can make sure that this is in the simplest radical form, checking our two things. Are there any perfect squares that go into 3? Not 1.
No.
No, right? It starts right here, so 1 is the only one less than it. Are there any fractions under our radical? No, so we're good. That is now in simplest radical form. Do one more that's very similar before we ramp up the difficulty. So is 25 a perfect square? Or 24 a perfect square?
Absolutely not.
Yeah.
It's not. So it starts right here. Does 16 go into 24?
No.
Does 9 go into 24?
No.
No.
Does 9 go into 24?
No.
Does 4 go into 24?
Yeah.
All right. So I want to write this as a multiplication problem with 4 times, and what is my other factor? 6. Now let's break apart our radical.
Oh, it's 4 times 6. I thought it was 4.6. I thought that's wrong.
So this is the square root of 4
I saw that. Makes me
times the square root of 6. And the point of doing this is we're going to be able to get rid of one of these radical signs. So what is the square root of 4?
2.
You should probably Google psychosis and realize something.
You should probably Google
And what is the square?
3.
It is.
No square root of 6.
Thank you. What is 3 times 3?
Hooligans.
9. So 6 is not a perfect square. It is not on my list. So this is 2 times the square root of 6. And we're done. What is your question?
It's not really on the phone, but why is 25 there if it is a perfect square?
Because it's not in reduced form.
Ah.
Okay, so going on. Now we're going to look at some variables. So this is the same thing as 25 times x squared, right?
Wait, I don't get why it's 2 and 6.
So square root of 4 is 2.
Maybe if you were paying attention instead of
That
talking.
I am.
All right, I want to throw in some variables. How are we doing, Lily? Lily, how are we doing?
It's
You okay?
Oh, the stick man.
All right,
Thank you for proving
Jack.
What?
So I can rewrite this, and this is kind of an unnecessary step. If you know that this is equal, that's fine. So this is the same thing as 25 times x squared. And I write it like this so I know I can break it apart. When I have a multiplication sign, I know I can write this as two separate radicals.
But why is it unnecessary to do that?
Because this is the same, exactly the same thing, right? That's an implied multiplication.
So
So this is the square root of 25
I'm gonna do 5
times the square root of x squared,
oh my god.
right?
What?
So
So
I-
the square root of x squared, what height does that?
All right, hold on. What is the square root of 25?
5.
5.
Ah!
All right, what is the square root of x? Angela, do you have a question?
What's that?
Actually, I'm just saying, like, some of this seems similar to what we did in section 9, like chapter 9. Like, trying to find out, like when you have those 4 polynomials.
Yep. There's a lot of very similar things. Very good. All right, square root of x squared. Maddie.
Sorry.
All right,
X.
it is x. So the square root, Maddie, the square root of x squared.
X.
Because I just told you to stop talking.
Well, yeah, but never mind.
All right, square root of x squared. We said is x. The square root function is the inverse of squaring. So undoes it. They undo one another. So we're trying to come up with two things. The square root, I'm trying to figure out what two things multiply to get what's underneath it. So what two things multiply to get x squared?
X.
X and x, right? We're trying to get two of the same thing. So the square root of x squared is just x. So this is 5x.
Hold it.
And I have no radicals, so it's definitely in simplest radical form.
Correct.
Oh my gosh. Yeah, I get this.
So this one's going to be a little trickier, but have faith.
I got faith.
So how might we split this apart? I'm going to skip this first step. How might I split this up? To be the square root of what and times the square root of what?
36 times X.
Times the square root of x to the 5th, right?
All
right. What can I do right away? What do I know?
36 is 6 times 6.
All right, so this is 6 times the square root, Kennedy, of x to the 5th.
It's correct, right?
All right, so this is where things get a little tricky. And it's when I have exponents of variables. So here's what I'm going to tell you. If you have a variable to an even power, it is a perfect square itself. Hold on. Okay? Because what times itself gives me x squared? X. What times itself gives me x to the 4th?
X to the 2nd.
X squared. What times itself gives me x to the 6th?
X.
X cubed. How are we figuring that out? We are adding 1. So whatever that power is to square it, we're going to divide it by 2, and that's unsquaring it. So the cube root, or the square root of x to the 10th is x to the 5th. Okay? So we can write a new list if you need to, and I didn't write these last hour. So bear with me. Because x squared is x times x. X to the 4th is x squared times x squared. Right? So the square root of x squared is x. The square root of x to the 4th is x squared. Even ones are perfect squares, okay? Does that make sense?
Yeah.
So that tells me that every odd exponent has a perfect square that goes into it. And what we're going to do is we're going to split it up like this. So I'm going to take x, so this is x to the 5th. This is the same thing, and bear with me, I'm going to kind of ignore the 6th for a second. So this is x to the 4th times x to the 1st, right? X to the 5th can be broken up to x to the 4th times x to the 1st.
I guess.
And what I'm going to tell you to do is every time you have an odd exponent, break 1 off of it. And then you'll have an even exponent. Once you have an even exponent, it's a perfect square. So this is the square root of x to the 4th times the square root of x. What's the square root of x to the fourth? X squared. So this is x squared times the square root of x. And now I'm just going to, this is 6 is being multiplied by all of this. I was kind of ignoring it. So if I bring that back down, so I have 6x squared times the square root of x.
Well, dang.
Do you want to do one more with an odd exponent? Okay. All right, so this is not on your sheet, but last hour asked me to do it in 2. So ignore my scribbles at the bottom here. So if I have the square root of a to the 7th power, if I'm going to do this for you, I want you to be listening. I've already done this once. All right, so square root of a to the 7th. I said to break off one factor of a. So how many is the big one going to be? So I want a to the 1st, and I'm multiplying it by a to the what? 6th, yeah. So this is a to the 6th times a to the 1st. Remember, when we multiply exponents, or two bases with exponents, we add them. So then this is the square root of a to the 6th times the square root of a, because a to the 1st is just a, right? Right? Are we okay so far? All right, what's the square root of a to the 6th? A to the what?
Oh, no.
Divided by 2.
3.
A cubed. So this is a cubed times the square root of a. We okay? Sarah, you look confused. Are you confused about this part? Okay. What's a cubed times a cubed? We add them. Okay? So it's a little confusing. But remember that we add exponents. So the square root of a to the 6th is a cubed. So just divide that exponent by 2 to get what it is without a square root. Are we okay with odd exponents now? Feel a little better? No, yes? Better than fractions? All right. This next one is a property that we really, really want to know.
It's a fractions.
It's this one right here that I want to talk about. Fractions really aren't bad.
They are.
Square root of 7 times the square root of 7. What is the square root of 7 times the square root of 7?
Square root 7 squared.
It is the square root of 7 squared.
Oh.
7.
It's 7. So when I do the square root of something times the square root of that same something, I just get plain something out. So think of this. So I'm multiplying square root of 7 times itself. So just like Allison said, this is the square root of 7 squared. And just like before, square roots and squares undo each other. So something squared, taking the square root of something squared, or squaring something that's under a square root, they get rid of each other. So this is just 7. Are we okay with that?
No.
Okay. So I'm trying to come up, what if this was, let's say this is 9 instead of 7. What's the square root of 9? What's 3 squared? 9. Which is what I put in.
If it's something times itself on square root, just write that number down.
Alright. So the idea here, so square roots and squares are intentionally made to do this. They are inverses of one another. So they're made to undo each other. That's how they're defined. Okay? So whenever you have something that's been squared and then, or something that under a square root, then squared, we get just that plain something back out. Okay? Similarly, if I had 7 squared, and I took the square root of 7 squared, we'd also get 7 back out. It doesn't matter which one comes first. Okay?
You got it, boss.
Alright, this is something we absolutely want to know. Okay, my next example, I know I can break things apart into their own radicals. Can I also push them together into one?
Yeah.
Yeah?
Yeah.
Okay. So that means this is 2x cubed times x, right?
Yeah, and then you can like that 2x. quadruple.
To the fourth. Cubed is as high as we have a word for.
That's so good.
All right. So we can, just like Jack is suggesting,
Quad.
girls in the back, this is 2x to the fourth. Do I have any perfect squares in there?
Yeah.
What?
X4.
X to the fourth is a perfect square. So I want to break this to be the square root of 2 and the square root of x to the fourth. Square root of 2, can I break that down? Should I leave it as it is? I'm going to leave it. There's no perfect squares that can go in there. And it's a repeating decimal, so I don't, or not even repeating, a never-ending decimal. So what is the square root of x to the fourth? X squared. So the square root of 2 times x squared. I'm going to rewrite this because we like to write our radical terms at the end. So this is going to be x squared square root 2. Are you okay with switching it? So you know, like, instead of writing x6, we write 6x. Same idea. Think of radicals as like another form of variable. So are we okay with this one? A little bit?
Can we do another one like that?
Yeah. I have to come up with one, sorry. All right, so I could break these up separately. What I'm going to do instead is I'm going to put everything under one radical and simplify them all at once. So how would I write this? If I move these all together, how would I write it?
4x to the fifth times x.
Okay. And what is that? 4 times x to the what? To the 8th. And now I want to break this up. So this is the square root of 4, the square root of x to the 8th. What's the square root of 4? 2. What's the square root of x to the 8th? X to the 4th.
Hey.
All right? Okay. Now we're going to look at some fraction ones. And these aren't nearly as scary as they look. So what we can do here is just like we were able to take multiplication and make 2 radicals, we're going to make this the square root of 25 over the square root of 49. So we can break it into 2 radicals, one on the top and one on the bottom. So what is the square root of 25? 5 on the top. What's the square root of 49?
7.
And we're done. We have no radicals, and they are now in simplest radical form.
What? Okay, what else?
So how can I simplify my last one?
That's off again.
What are we going to put on the top?
11.
Not just 11, the square root of 11. And on the bottom? That's a d, isn't it?
Oh.
Square root of d squared? Okay. Are there any perfect squares that go into 11?
No.
No. So we're just going to write it as the square root of 11. Are there any perfect squares that go into d squared? D squared is a perfect square. So the square root of d squared is d. And now the only radical we have, we're done. So we don't have any fractions under our radical. It's not in this part right here. And this doesn't have any perfect squares, so we're all set. How do we feel about simplest radical form?
Simple.
It's confusing.
Is it a little okay?
No, not at all.
Alright. So now I want to add and subtract with radicals. So what I want us to think about this, it's okay, is like terms. Sophie, what'd I say? Okay. Way too much talking. Alright, so adding and subtracting radicals. So think of the square root of something as some sort of variable to a power. So I have 1 square root of 14 plus 1 square root of 21 minus 4 roots of 14. Which ones are the same? So here I have a square root of 14, and here I have a square root of 14. So those are going to be our like terms.
Oh, they're all divisible by 7.
Those numbers are all divisible by 7, but they're not like terms. Alright, so I want to put my like terms by each other. So I have a square root of 14, I have minus 4 square roots of 14, and I'm going to put my plus square root of 21. So I have 1 root of 14 minus 4 roots of 14. How many roots of 14 am I left with?
-4. 1.
1 minus 4.
3.
Negative 3. So now I'm left with negative 3 roots of 14. And then I still have my 1 root of 21.
Man, these things are sure radical.
And we're all done. It's as simple as it gets. Does that make a little sense? Thinking back to like terms and adding and subtracting like terms. Okay. Do I have any like terms in my next one?
Yeah. Wait, no.
I don't.
Nope.
But what's wrong with the square root of 28?
It's not 29.
Thinking back to the front side of my page,
There's no square root. No perfect square.
it is not in simplest radical form. So what perfect squares go into 28? Does 9 go into 28?
No,
Alright, let's go back. Here's where 28 is-ish. Does 25 go into 28?
Yeah. Well, I mean, it goes
No.
into it, but there's some left over.
It's so we want perfect factors.
Four does.
So 16, does 16 go into 28?
Yeah.
No.
No. No. Jeez.
Does 9 go into 28?
No. It's 4.
Does 4 go into 28?
Yes.
Alright. So the square root of 28, let's make this simpler. Oh, I'm sorry. Absolutely. So if we simplify this, this is 4 times 7. So this gives us the square root of 4 times the square root of 7. And if I simplify that even more, what do I get? What's the square root of 4?
2.
2.
2 times.
2 times the square root of 7. So I'm going to rewrite this with my new simplest form. So I have 2 times the square root of 7 plus 2 times the square root of 7.
Whoa. No way.
Right? So I have 2 roots of 7 plus 2 roots of 7. How many roots of 7 do I have?
2.
The square.
4. I have 4 roots of 7. And we're all done. So I had 2, I added another 2, and now I'm left with 4 roots of 7. Alright. Let's do one more of the adding ones. So I do not have like terms, right?
9.
But what perfect squares go into 6? Do any perfect squares go into 7?
No.
No.
No. Do any perfect squares go into 63? Probably? Alright, let's look.
36. No.
No.
16.
Alright, here's my, what did I say, 63? Alright, 63 is about here. Does 49 go into 63?
No.
Yes.
36?
Yeah.
No.
25?
Yes.
No.
No.
Jacob.
It's 9.
What?
Does 16 go into 63?
Yeah.
It does?
No, it doesn't. It's 9.
Does 9?
Yes.
Alright. So let's break. Oops, sorry. So we take the square root of 63. We said that has a 9 and a factor. So what else does it need to be multiplied by? 7. So if I break this to be the square root of 9 times the square root of 7, Alright, so what's the square root of 9?
3.
3 times the square root of 7. So now I'm going to put that into where square root of 63 was. So we have 2 square roots of 7, 2 roots of 7 plus 3 times 3 roots of 7. Make sure that you get both those 3's in there. So how can so I'm going to simplify this once more before we try to add them. So I have 2 roots of 7, and I have 3 times 3 roots of 7. How many, or what is that?
Well, it would be 8 times.
What's 3 times 3?
9.
9.
Oh, I have.
So we can multiply those. Okay? So we have two numbers. This is all multiplication, so I can multiply the 3 and the 3. Okay, so now I have 2 roots of 7 plus 9 roots of 7. And I end up with 11 roots of 7. Good. So I have 2 roots of 7 plus 9. So 2 and 9 gives me 11. Okay? Or think of this as 2x plus 9x. That's 11x, right?
Yeah.
All right. Now a little bit of multiplying. We're okay. Yes. All right. A little bit of multiplying. So thinking back to our warm-up and our distributive properties, I'm going to distribute my square root of 3 out. So I'm going to multiply it here, and I'm going to multiply it here. So what is the square root of 3 times 2? Right, it's just 2 times the square root of 3. So one is under a radical and one isn't, so we can't multiply them together. And we'll bring down our addition sign. Now we have the square root of 3 times the square root of 12. So it's the square root of 3 times 12, right? I can write it that way? So I'm going to just simplify. So 2 roots of 3. What's 3 times 12? 36. I think I can simplify this a little bit more. What is the square root of 36? It's 6. So I have 2 roots of 3 plus 6. And we're done. The only radical I have has a 3 under it, and there are no perfect squares that go into 3. The next one is a little scary, but it probably looks a lot like something we just did. So who remembers how to multiply binomials?
You make a box and then you do that stuff.
I would make a box.
Some other stuff.
So if we have square root of 2, square root of 5 on the top, square root of 2, and I have minus 3 roots of 5, and we can multiply. Do you remember our box? Move up. So my first one, what is the square root of 2 times the square root of 2? Square root of 2 times the square root of 2.
Square root of 2 squared.
Which is?
4 squared. Oh, why? I'm so confused right now.
Square root of 2 times the square root of 2. It is the square root of 4. What is the square root of 4? 2. Right? The square root of something times the square root of the same thing as itself. Alright. Here I have the square root of 5 times the square root of 2.
Square root of 7.
What do we need to do with those numbers?
Multiply them.
We're multiplying them.
Square root of 10.
So this is square root of 5 times square root of 2. Square root of 5 times 2. Square root of 10. If you need to think about your steps. Alright. I'm going to show, I think I need a little work. So I have the square root, or negative 3 square root of 5 times the square root of 2. I know I want to show a little work. So I have two things under a radical that are being multiplied. So I'm going to put those under the same radical. So that's square root 5 times 2. And what does that give me? Negative 3 times the square root of 10. So that we can put into this box. All right, we have one more. So I have negative 3 times the square root of 5 times the square root of 5. What's the square root of 5 times the square root of 5? It is the square root of 25.
5.
It's 5. So we can write this as square root of 25. So we get negative 3 times 5, which is what? Negative 15. All right, so now I've filled in my box. And what do we do with all the numbers in our answer?
Combine like terms.
We're going to combine like terms. And how are we writing them?
Addition.
Addition. So I have 2 plus the square root of 10 minus 3 roots of 10 minus 15. Where are some like terms?
The 10 and the 3, 10.
All right, so our roots of 10, right? I have 1 root of 10 minus 3 roots of 10. How many roots of 10 am I left with? I have 1 minus 3.
It's negative.
Negative what? Negative 2, right? I have a positive 1 and negative 3.
Yeah.
So now I'm going to write this as 2 minus 2 roots of 10 minus 15. Do I have any other terms I can combine? The 2 and the negative 15. What is 2 minus 15?
13.
Is it?
It's negative 17.
I have positive 2 and a negative 15.
Oh, yeah, it is.
Negative 13, right? I'm starting a little positive. I'm going a lot more negative. So I can write this as negative 13 minus 2 roots of 10. And all of my terms are combined. Is this in simplest radical form? Yeah, we're all done then. So that is our, that one's a lot of steps, yes. All right, so this last connections to previous sections, that is for you to do on your own. We still have a couple minutes left of class, so I would fill that out.
We have to?
Yes.
Is it going to be in our portfolio?
All of your notes are going into your portfolio.
No, Joe.
Your homework is still on the front sheet of your portfolio sheet under today. So today is Thursday. So make sure you're doing that. And that's your homework for tonight. Make sure you fill out your connections to the previous sections and the homework from 11.2.